Okay, so in this segment, we're going to introduce the first of our 3 trade models. This one is the Ricardian model. In this model, we're going to look at technological differences as being the foundation for the gains from trade. This is going to be in contrast to other models, specifically later on the Heckscher-Ohlin model, where we're going to look at differences in factors of production, how much labor, how much capital, how much skilled labor different economies have as being the foundation for trade. So we start off by looking at technological differences. Now, one of the things I want to point out here is that we're going to be agnostic as to the source of those technological differences. We're just going to take them as a given. Now, one of the themes we're going to have throughout the entire course is keeping the models as absolutely as simple as possible in order to illustrate the mechanisms that could possibly lead to trade or gains from trade, gains or losses for different groups. So in order to keep things as simple as possible, we start with 2 countries. So our Ricardian model is going to have 2 countries and 2 goods or services. We're going to focus on goods. So number of countries, number of goods, and then the third thing we have to specify is the number of factors of production. And in this model, it's the simplest one we're going to talk about. There's only one factor of production, and that is labor. So this is a 2-country, 2-good, 1-factor of production model. And you'll see that the next 2 models we do, the next 2 chapters, we're going to keep the first 2 parts the same, 2 countries, 2 goods, but we're going to have different factors of production. Now, one thing that we're going to develop here, and you probably saw this in Principles of Micro, in fact, you should have seen this in Principles of Micro, is the notion of comparative advantage. As opposed to absolute advantage. Now, absolute advantage refers to the fact of a country being just flat out more productive, being able to produce something with fewer inputs at lower cost. So it's a direct comparison. Whereas comparative advantage is a relative comparison. So I want you to hold that in your mind, and we'll talk about this in the context of a specific example. So we're going to start everything off. We always start off talking about the home country first. So what we need is 3 pieces of information. We're going to have the marginal productivity of labor in wheat, which is our 1 good. We're going to say that that marginal productivity is 4. What does that mean? That means that each worker can produce 4 bushels of wheat. The productivity of workers in the cloth sector, which is our 2nd good, is 2. So each worker can produce 2 yards of cloth. So if you take a worker, you can have them producing wheat, and if they produce wheat, they'll produce 4 bushels of wheat. If they produce cloth, they'll produce 2 yards of cloth. The third piece of information we need is the total labor supply or number of workers. And for our example, let's say there are 25 workers in the home country. So what are we going to do with all of this information? It doesn't seem like a lot, right? Just 3 pieces of information. But this is going to let us develop the production possibilities frontier for the home country. And we're just going to decide we're going to put wheat on the x-axis and cloth on the y-axis, just so that we're all on the same page, putting the same goods in the same axes. Everything we do, you could flip the axes around, it doesn't make a difference. So what does the production possibilities frontier tell us? The production possibility frontier shows us all of the combinations of, in this case, wheat and cloth that can be produced with these 25 workers, given the production technology. Okay? So we said a few minutes ago, we're focusing on differences in technology. And those technologies are reflected in these marginal productivities right here. Okay? And again, we're going to be agnostic about where those differences come from. We're just going to take those as a given. Okay? So how do you develop the PPF? Let's start here on our x-axis. If you took all 25 workers and put all of them into the production of wheat, how much wheat would you be able to produce? You take 25 times 4 would give you 100. Okay. And that's what the intercept here on the x-axis is giving us. Now, this is saying if you put all of your labor into wheat, what is the maximum amount of wheat that you could produce? In this case, it would be 100 bushels. On the other hand, what if you took all 25 of those workers and you put them into producing cloth? Well, each worker can produce 2 yards of cloth. 2 times 25 gives us 50. And if we just draw a straight line between those two, that gives us the PPF. Now, why is that a straight line? Okay, start down here at the point where we have all 25 workers producing wheat, nobody in cloth. So what do we have? We have 100 bushels of wheat, no cloth. Now take one worker out of wheat production. What's going to happen to your wheat production? It's going to go down by 4 to 96. And your cloth production will go up from 0 to 2. Again, take this now one more worker. Take a second worker out of wheat. Production would go down to 92. And for cloth, it would go up to 4. Right? And as you do that, you draw out that, do that worker by worker, that's what gives us the PPF. Now, what's the important thing to note here? Notice that this trade-off is constant. What's happening? Every time I take one worker out of wheat production and put that worker into cloth production, what's happening? I'm gaining 2 yards of cloth, and I'm losing 4 bushels of wheat. Okay? So my trade-off here is 2 for 4 or 1 to 2. And what's so special or what's so important about that trade-off? That is the opportunity cost. Right? And the opportunity cost of what? Well, it's the opportunity cost of producing more wheat. Okay? We always state our opportunity cost in terms of the good that is on the x-axis. Right? So I stated it in terms of starting down here where we're producing nothing but wheat, but you can flip that around and start up here where we're producing only cloth and no wheat. Right? So logic works in both directions. If I start from here, if I'm producing 50 yards of cloth and no wheat, and then I take, so I've got all 25 workers in cloth production, and I take one worker out of cloth and put that worker into wheat, what am I going to have? I'm going to lose 2 yards of cloth and gain 4 bushels of wheat. In other words, each additional bushel of wheat that I'm producing is costing me a half a yard of cloth. And so that 1/2 is the opportunity cost of producing more wheat. And if you flip that around, the change in the quantity of wheat over the change in the quantity of cloth, which is 4 over 2, or just 2, that is the opportunity cost of producing cloth. Right? We always state the opportunity cost in terms of what are you giving up divided by what you're getting. Okay? That's our opportunity cost. And what you should note here is that the opportunity cost of producing wheat, the good on the x-axis, is simply the slope of the PPF. Okay? So now that's it. That's all there is to the PPF. This society with 25 workers, where each worker can produce either 4 bushels of wheat or 2 yards of cloth, can produce any combination of wheat and cloth that's on this PPF. Now, you could produce less. You could produce at a point, like say there, point X, But why would you? Why would you produce less than you're capable of? That just means that people aren't working. You absolutely cannot produce outside of your PPF. And so that PPF constrains your production. Now, if you think about a closed economy, right, one where there's no trade, you can only consume what you as a society produce. So that PPF not only constrains production, it also constrains your consumption. How do we show consumption? Well, now we have to add the other side of the model, right? The PPF and our production technologies over here, our quantity of labor and our marginal productivities, those tell us what the society is capable of producing. And as just stated, they can produce any combination on this PPF. The question is, which of those combinations is the best one for society? In order to find that, we need to introduce the demand side of the model, which we illustrate with indifference curves. Right? So what is an indifference curve? Well, an indifference curve shows us all the combinations of cloth and wheat that yield the same level of utility. And so let's call that U0. So in this indifference curve, what we're saying is this point here, A, where you're getting this amount of cloth or wheat, rather than this amount of cloth, gives the same level of well-being to the members of our society as point B. So we'd say that society would be indifferent between points A and B if they give the same level of well-being. Now, higher indifference curves, say like U1, reflect higher levels of utility. You would rather be up on a higher indifference curve. And it's easy to illustrate that by picking a point like C. Now, what's true at point C? If you compare it to point A, what do you notice? Compare C to A. At point C, the society would be consuming more wheat and more cloth at C than they would at A. So clearly, that would be a better point. Right? You're getting higher level of utility, higher level of well-being when you're consuming more of both. Otherwise, if you focus again back on our points A and B, what you should notice is that there's a trade-off. Right? If I'm going from B to A, I have to give up a certain amount of cloth in order to gain this additional amount of wheat. Okay. So now we're going to put these two together. Our PPF shows us all of the combinations of wheat and cloth that the society can produce. And importantly, that slope of the PPF, like the opportunity cost of producing wheat, tells you the trade-off the society is forced to make between wheat and cloth production if it wants to produce more wheat. And moving in the opposite direction, right, the inverse of that is the opportunity cost of producing more cloth. Right? How much wheat do I have to give up if I want to produce another unit of cloth, right, another yard of cloth? So the PPF tells us the trade-off society has to make, and the indifference curves give us the trade-offs that society is willing to make, right? Willing to make in terms of consumption. So we put those two together by bringing our indifference curves into our graph with our PPF. And what we're looking for is a point of tangency. Right there, right? The point where that indifference curve just barely touches the PPF. And what is true at that point? At that point, and we'll call that our equilibrium point, our equilibrium point A, at that point, what is true is that the slope of the PPF equals the slope of the indifference curve. Now, conceptually, why is that important? Well, think back to what I just said about 2 minutes ago. The PPF shows you the trade-off the society has to make between producing the two goods, right? That's the change, right? And what's that slope? It's the change in the quantity of cloth over the change in the quantity of wheat that society has to make, right? And again, what do we mean by has to make? It's dictated by the marginal productivities, right? Technology dictates that trade-off. And in this case, that trade-off is 1 to 2. Right? If I want to get another bushel of wheat, I have to give up half a yard of cloth. Well, in equilibrium, that trade-off, that 1 for 2 trade-off, is going to be equal to the slope of the indifference curve, which is, again, measured in terms of the change in the quantity of cloth over the change in the quantity of wheat. So in equilibrium, right, what is the point that gives us that equilibrium, this point A? That's the point where the trade-off that you're forced to make based on technology, based on the productivities, is equal to the trade-off you are willing to make as a society in terms of your consumption. And we call that an equilibrium, a stable equilibrium point, because there's no incentive for society to deviate from that point without any external changes to our model. Now, where do these indifference curves come from? Well, they come from a utility function. I'm not actually going to ask you guys to work with utility functions in this class. We'll just give you indifference curves and have you work with them graphically. But you can just take it that, take it on faith, if you will, that they come from these utility functions. I will actually ask the graduate students to work with those a little bit, but not the undergraduate students in the class.